right, so today we're going to talk about the ellipse, and the generic form of the equation is the quantity x minus h squared over a squared plus the quantity y minus k squared over b squared equals 1. So as we've seen in the past, the center would be at h comma k, so it's the opposite of what you see with the x minus h, and it's the opposite of what you see with the y minus k. The major axis, it has a length of 2a, and the minor axis has a length of 2b. So being that the major axis is related to the x minus h squared portion, that means that if I have the center of my ellipse, it's going to be longer horizontally than it is vertically. And that's how you make your ellipse sketch. All right, the other thing we have to answer is where is the focus? So between the two endpoints along the major axis, there are two focal points, a certain amount of distance away from the center. So we're going to approximate these. This is focal point 1 and focal point 2. So the focus is h plus or minus whatever the value of c is, comma k. And c squared is equal to a squared minus b squared. All right, the secondary case is where the ellipse is longer vertically than it is horizontally. So it's a very similar equation, except since a is always going to be larger than b, then the major axis in this one would be vertical because it's in the denominator of the y fraction, right? The center is still going to be hk. The major axis will still be twice the length of a, and the minor axis will be twice the length of b. And the foci will be at h comma k plus or minus c. And again, where c is c squared equals a squared minus b squared. All right, so I'm just going to add that equation in here so that we don't forget. C squared equals a squared minus b squared. And another way to say it is that c is equal to the square root of a squared minus b squared. The eccentricity, which is a measurement of the shape of the ellipse, and that is equivalent to the ratio c over a. Eccentricity is always between 0 and 1. When the eccentricity is equal to 0, that's when you have a circle. And if the eccentricity is equal to 1, then this would be a parabola. When it's between 0 and 1, then it's an ellipse. All right, the foci are the endpoints of the focal axis. And that's pretty much it for vocabulary for that section. All right, so let's move along to some practice problems. All right, so we have 4x squared plus 9y squared equals 36. And if you notice, each of the generic equations equal to 1. So in order for the 36 to turn into a 1, we would need to divide all parts of the equation by 36. Then we're going to reduce. So 4 over 36 is 1/9, which would mean this is x squared over 9, plus 9 goes into 36 4 times, so this would be y squared over 4, and that should equal 1. So for an ellipse, you always want it to be equal to 1. And there's your equation. But now we should answer some of our questions that will help us graph. So the center is at 0, 0 because there's nothing being added or subtracted to x or y. The major axis is the longer of the two axes. And so we look at the denominators. We've got a 9 and a 4. The 9 must be the larger value, but that's really a squared. So we want just a, which would be 3. And in order to find the major axis length, we would double that 3. So it's really 6. And then the minor axis, that's going to be related to the 4 in the denominator, because remember 4 is less than 9. So If I take the square root of 4, that gives me b to be equal to 2. And so 2 times 2 is equal to 4. All right, for the foci, we're going to have c squared equals a squared minus b squared. And a squared was 9, b squared was 4, and if I subtract those and take the square root, I get c equals square root of 5. So we're going to go left and right 3 units. Put a dot. That's the endpoints of the major axis. And then for the y direction, if you look what's underneath the y squared, we got a 4. Take the square root of that, that's 2. So that means we're going to go up 2 and down 2. All right, so we've found our center. We dealt with the major axis, right? And if you double check, it really is 6 across. That's the major axis. And 4 up and down is the minor axis. And then we do need to plot some foci on here. So we know that they each have to be the c distance away from the center. So we know that we're going to take the center and move over. Square root of 5 is a little more than 2. So do an estimation right there in each direction, right? But that doesn't answer the question about where the foci are actually located. So they are at plus or minus root 5 comma 0. So they didn't have any change in a vertical direction, just the horizontal direction. All right, and then the eccentricity. So remember, the smaller the number, closer it is to 0, the more it's going to look like a circle. If you have a super elongated ellipse, then as it approaches 1, it'll look more and more like a parabola. All right, so we just need to do E equals C over A, and C is root 5, and A is the 3. All right, so that gives us the eccentricity value. All right, so let's continue on with solving this equation. We want it to equal 1, and right now it equals 5. So if I were to divide everything by 5, that should take care of the problem. Now it does introduce a few extra problems because now we've got 15 over 5x squared. Well, we need something in the denominator, so really we're going to need to do x squared over. Instead of having a 3 over 1, we would have a 1/3 on the bottom. And instead of having 3 over 5, we would have a 5/3. All right, so that is my ellipse equation. All right, my center is going to be at 0, 0, because it's not being shifted up, down, left, or right. So now I need to find the length of the major axis. So remember, a squared or b squared is underneath the x squared and the y squared. We need to look for the larger of the two, but 5/3 is definitely bigger than 1/3. So that is equivalent to a squared. But what we need to do is find just regular a. So a would be the square root of 5 over the square root of 3, and we would rationalize that. So if we multiply by root 3 over root 3, we get root 15 over 3. All right, so the length of the major axis should be twice that, so it'll really be 2 root 15 over 3. All right, so for my minor axis, we should be looking at what is the value of b, and I know that b squared is equal to 1/3, so that means that b is equal to the square root of 1 over the square root of 3, but I can't leave it like that, so I would multiply by root 3 over root 3, and I get root 3 over 3. All right, so my minor axis needs to be twice that, so I would do 2 times root 3 over 3. All right, so the foci, remember that's going to be c squared equals a squared minus b squared. And a squared is equal to 5/3 minus 1/3. And that's a good reminder that since you're subtracting, the larger number goes first. You're always going to get a positive number. If you subtract and get a negative number, then you know you have something mixed up because the negative cannot be equal to a c squared. All right, so first c squared should be equal to 4/3. And if I take the square root of that, that gives me 2 over root 3, which we need to simplify or rationalize. So it's c equals 2 root 3 over 3. All right, which means that I need to add that as a change in the y direction because the major axis should have the focal points on it and the focal axis on it. So I'm going to start at the 0, 0, and I'm going to go up and down 2 root 3 over 3, but that's a change in the y direction, so the x does not change. Let's go back to the concept of eccentricity. That is E equals c over a, and c is equal to 2 root 3 over 3, but over a is root 15 over 3. All right, so let's remember how to simplify complex fractions so I can get rid of the 3's. Then I'm left with 2 root 3 over root 15. Now I know I could reduce 3 over 15, so that would give me 2 root 1 over root 5. And if I rationalize that, I would get 2 root 5 over 5. All right, the final thing we need to do is graph. So let's look at where the center would be. I know that's at 0, 0. And if we take a look at the major axis being 2 root 15 over 3, a would just be root 15 over 3, so that's about 1.29. So we'll go up and down 1.29 from the center at 0, 0. And then for the left and right, we're going to go 2 root 3 over 3 divided by 2, which is just root 3 over 3, which means we'll go 0.577 to the left and right of 0, 0. And that would give us our endpoints of our minor axis. And then we will just draw in our ellipse. All right, number 3. This time for 3 and 4, what we need to do is complete the square. All right, so as a reminder from earlier in the chapter, we're going to group together any x's. We're going to group together any y's. And any constants should go to the other side. All right, so we know we need to factor out a 5 to get x squared minus 8x, and then I'm going to leave a space to add something. We'll come back to what that something is in a minute. And then for the y's, I'm going to take out a 3, and I get y squared minus 12y plus something equals 188. All right, so now I need to figure out what am I adding? What's half of negative 8 squared? That's going to give me 16. And half of negative 12 is 6, so 6 squared is 36. All right, so I need to just factor this trinomial, and I get x minus 4 squared plus 3 times y minus 6 squared equals, now remember we got to add, if we did adding 16, it's really 5 times 16. And if I add a 36, it's really 3 times 36. So I'm going to add up 188 plus 80 plus 108, which actually gives us a 0. All right, so normally we would have it equal to some number, and then we divide by that number to get it to equal to 1, but we won't be able to do that here. So this is called a degenerate ellipse. I guess the one thing I could answer is where is the center, which is at 4, 6. One more example problem like these, and then we'll move on to something else. So again, we want to isolate the x term. So we got 25x squared plus 100x. And then I need to isolate the y terms and keep the negative 100 to the other side. All right, so I know I'm going to factor out a 25. I'll get x squared plus 4x plus something. And then in the next set of variables, I'm going to factor out a 4, and I get y squared minus 10y. And I know that I'm missing something, and that equals to negative 100. All right, so now how do we complete the square? We're going to look at half of the middle term squared. So 4 over 2 is 2. 2 squared is 4, which means this will factor into 25 times x plus 2 squared. And then for this one, we want half of negative 10. That's negative 5 squared is 25. So we would do 4 times y minus 5 squared equals negative 100. But that's not really negative 100 because we need to also add 25 times 4 plus 4 times 25. So that looks like it's going to give me positive 100. Now we need this really equal to 1. So I'm going to change again with my colors, and I'm going to divide everything by 100. All right, so working left to right, we got 25 over 100. That's 1/4, which means I'll have 4 in my denominator. And the x plus 2 squared is the same. All right, the second one, 4 over 100 is 25. So I'm going to have a 1 over 25 times y minus 5 squared equals 1. All right, so there's my equation. Now we need to know what to do with it. All right, so I know that my center is going to be the opposite of the x's, so -2, and this opposite of the y's, which is really going to be +5. All right, so that takes care of my center. My major axis is the one that is longer of the two. So we have 25 at the bottom of the y fraction. So if I take the square root of that, that gives me 5. And if I double it, that would give me the length of the major axis. That would be 10. All right, for the minor axis, I need to take the square root of 4, which is 2, and then double it, which is 4 again. So the minor axis has a length of 4. All right, let's look at focal points. So I know that the foci have to be c squared equals a squared minus b squared. So 25 minus 4 is equal to root 21. Well, if I take the square root of that, it's equal to root 21. And so I know that I have to go root 21 in each direction towards the major axis. So instead of being at just -2 comma 5, it's at -2 comma 5 plus or minus root 21. All right, and then the last basic question is, what about the eccentricity? So that is E equals C over A. And C is equal to root 21. And the reason for that is because the foci, that is equal to just C. All right, over A, which is the larger of the two denominators, take the square of that, that's 5. All right, so that is my eccentricity. All right, last thing I'm going to do for this problem is to graph it. So I should start at -2 and +5. And from there, I want to do, my minor axis is 4, so I just want to do 2 in each direction. But then my major axis is 5 in each direction along the y's, right? So that's going to get me all the way to the x-axis and then 5 up. I'm just going to extend this over. All right, so now we've got our ellipse. All right, so for this last set of problems, we're going to work backwards, and we are given information about the ellipse, but then we need to create the actual equation. All right, so if the major axis is 10 units long, then I know that 2a is equal to 10, which means that a is equal to 5. All right, if the foci are at 0, comma, plus or minus 2, that tells me that c is equal to 2. And since I know a and c, I can find b. And for all ellipses, c squared is equal to a squared minus b squared. So I've got 5 squared minus b squared equals 2 squared. So if I add b squared to the other side, I get b squared equals 25 minus 4, which equals 21. So b is equal to root 21. Now I need to look at which direction the focal axis is going. And so if it's from 0, 2 to 0, -2, my focal axis has to go vertical, which means my major axis has to go vertical. So this root 21 portion is related to the minor axis, so that would go horizontal. So I know that root 21 should go underneath the x squared. So root 21 squared gives me just regular 21. And then for the y squared, that's going to be the 5, and 5 squared is 25, and then these should always equal 1. All right, problem number 6, they give us focal points, so those are at 3, 0, and -3, 0, and the vertices are at 5, 0, and -5, 0. So I know that underneath my x squared, that should be my a squared. All right, so I know that the center has to be at 0, 0. I guess I should have mentioned that for the previous problem, since the focal points have to be same number of units away from the center had to be at 0, 0. So going back to number 6, I know that I should have this generic format. Oops. And since they give me focal points, that gives me C. So C is equal to 3 units. I know that A is equal to 5 because the vertices have to be the end of the major axis. So that gives me a couple things. So I know that underneath the x squared should be 25 because 5 squared is 25. And then we need to know what B is. So if we have C squared equals A squared minus B squared, I've got 3 squared equals 5 squared minus B squared. So if I add B squared to the other side, I get B squared equals 25 minus 9, which is 16. And B is equal to 4. Now to make my equation, I just want to square it again. So I probably could have avoided the square root and then square again. But that's going to give me 16. And then that's my final answer. All right, so for number 7, we know a couple of things. The eccentricity is equal to C over A, which is equal to 1/4. But that doesn't exactly mean that C is 1 and A is 4. It could be 2 over 8 or 3 over 12. So we just know it reduces to 1/4. So I don't have enough information to actually find anything from that. But I do know that the vertices are the endpoints of the major axis. And if they go to 4, 0 and negative 4, 0, I know my A has to equal 4. All right, so if I use this eccentricity equation, I get C over 4 equals 1/4. Well, now C definitely has to equal 1. Right, I've got A, I've got C, I just need to find B. So I know that for all ellipses, C squared equals A squared minus B squared. And C is 1, A is 4, and I just need to find what B is. So if I add B squared to both sides, I get B squared equals 16 minus 1, which is 15, and B is equal to root 15. All right, since my vertices are the endpoints of the major axis, the center has to be right in the middle of those 2 points, so the center has to be at 0, 0. All right, so I know it's just going to be plain old x squared and y squared equals 1. And I know that the a squared has to go in the horizontal direction, so that would be 4 squared or 16. And then the root 15 squared would give me 15. All right, and then we are all finished for the day. Have a nice day.